gather statistics, create an index on this object type. And if we just do a quick look at the index, we can see that in the index there's 71,411 rows. In the table, there's 71,482 rows. There's 71 rows in the table that are not in the index. So not everything inside of the table is pointed to by the index. Select star from the table where object type is null, full table scan. It has to. The 71 rows we're interested in don't exist inside of the index. We're looking for the null ones. And this is probably the #1 case or reason why a lot of developers won't ever use a null value in a column. They'll stick in some fake value. Like if object type is null, we'll actually put in XXXXX. Funny but true story. A guy in Florida got a license plate of XXXXXX. Guess what the default value used by the developers of the ticketing system in Florida was? XXXXXX. Guess who got all the traffic tickets whenever somebody wrote a ticket and they didn't know what the license plate of the car was? That one guy. They had to change the system. They had to go back. First, they asked the guy, can we take your license plate back? And he's like, no, I really like it. So they had to change their software to use a different default value. But what default value can you use for a license plate? XXX, XXX seemed like a really good choice. Null would have been the right value. I don't know. But a lot of people will avoid that because they think a query of this form always has to full scan to find that data. Even if I ask Oracle, beg it, please use the index, it refuses because it cannot. The answer doesn't exist there. Drop that index, do that little trick that I just demonstrated. Add 0 to the end of it. 0 is really small. Won't make the index that much larger, but allows me to use the index to go after those null values. So this is a little bit of metadata matters, as well as understanding how indexing works inside of Oracle. Anytime I have at least one not null attribute in the index, that's going to open up access paths that never existed before. Tell us how the tables relate to each other, and we might be able to remove them from the plan. This is an interesting one. This was only added recently, 10G, I believe. Have an employee table, have the department table. We're going to pretend that these two tables are big. I'm lying to the optimizer and telling it that the employee table is 1 million records, and the department table is 100,000 records. I create that generic view. I'm not going to use a view in this example, but suppose I created the generic view that selects columns from both emp and dept and joins them together. This is what my end users use to report on. Now, in real life, this might be a 5-table join or a 6-table join. If I only select information from the employee table as a result of this join, what does the optimizer have to do? In this case, it thinks it has to go against the department table and the employee table, join them together in order to return the results. Even if I threw an index on there, it's still going to assume that it has to go to the department table and the employee table to return the results because it's missing information. What information is it missing? It's missing the fact that the department column in the department table is unique, so that when an employee record is joined to the department table, the employee record will only appear once in the result set. And furthermore, it doesn't know that every employee record that has a department number filled in has a match in the department table. So it knows when I join emp and dept together that the employee table is this thing which the database calls key preserved. Each record in the employee table will appear at most once in the output. It won't be duplicated because of the primary key, and it will appear at least once if it has a department number filled in because of the foreign key. As soon as the database knows this, when we run that same query, look at the plan here. Well, initially, this is our old plan, and it morphs into this new plan. This is the plan after adding the constraint. I just have a full scan of the employee table. Department table is not even referenced, but there's a new filter there. emp.depno is not null. The optimizer knows, given the primary key and the foreign key, that that two-table join is the same as a single table query filtering out any row where dep/no is null. That's the only set of rows that would not appear inside the query plan. All of a sudden, those views that I create for reports, if I have the constraints in place on the base tables, can run more performantly now. I can actually remove unreferenced tables. You don't have to do it. The optimizer does it. This is how the tables relate, and we have more access paths available as well. Not only can we remove tables, but we have different ways that we can process your query. Same example, emp and dept. They're big. We create a materialized view as a join of those two tables. A materialized view is just a pre-answered query. We have department number, department name, and a count of how many people work in that department stored. It's physically there on disk. This materialized view has at most as many rows in it as there are rows in the department table, because of the way we wrote the query with the group by. So I set the statistics on that so the optimizer knows that this materialized view and the department table are about the same size. The employee table is 1,000,000 rows. We ask a really simple aggregate question. How many people work in the company? You know and I know we could have gone to this materialized view, add up all those counts by department, and that would give us the answer. The database, it does not know that yet. It's missing 3 vital pieces of information. The 3 pieces, primary key on the department table, foreign key on the employee table, and in this case, because we want to know how many employees, all of the employee records, we have to also tell the optimizer dep/no is not null because of the nature of the question that we're asking. And in fact, in our employee table, department number should be not null. Everybody is assigned a department. Once the optimizer has those 3 facts, that same select count star from emp does a materialized view rewrite against the materialized view. The cost of this query has gone down significantly. It takes a lot less resources to count 100,000 records and add up the counts that are associated with it than it does to full scan the employee table and add up how many records there are. This materialized view is skinnier than the employee table, and it's also a lot shorter. So the cost of this was significantly less. A lot of times, though, people say, oh, this is my data warehouse. I can't afford to have constraints. They're too slow. They slow down my loads. I read someplace on the internet that said, turn off constraints in your warehouse. You know your data is good. Just load it without it, and then run queries. Having constraints will slow down your load. My response to that is, you load once, and you query over and over and over again. Which process do you really need to optimize? Something you do once or something you do 1,000,000 times? Every time you run a query, if we're missing those constraints, we've lost out on opportunities to come up with more efficient ways to get the answer to you. So I'm going to show you another way to do these constraints in a data warehouse in a way that does not impact the performance of your load at all. But I'm also going to show you a side effect of using this technique. So I disable my primary foreign key and null constraint, and I insert an employee into department 1. I really only have 4 rows in my department table, and we all know that those are for departments 10, 20, 30, and 40. There is no department number 1, but I now have an employee that works in that department. Refresh my materialized view. Now I tell the database about these constraints. I put the metadata in the data dictionary, but I do it in a way that doesn't touch the database tables. I can tell the database that department number is in fact unique in the department table by adding the constraint in a mode that's known as rely on this constraint being true. Disable, don't do anything to enforce it, don't create any indexes, don't do anything special, no validate. Don't touch the existing data, don't look at it. All this does is writes into the data dictionary, primary key. The second one does the same thing for the foreign key. The third one does the same thing for that not null constraint. So you can add these things on without impacting your load performance.